Okay, hi. So I'm Charles Garcia-Tobin. I work for ARM. I started out there as a power management guy, and then gradually through ACPO power management pulled me into all manner of other specs. So I work on, I'm kind of the UEFI representative for ARM, and I work across a number of specs. And I was asked to give an update on a description of ARM Trusted Firmware, and also an update on what we're doing in SCT. So that's what I'm going to talk about. So to talk about ARM Trusted Firmware, what I'm going to give you is a bit of a historical perspective of why it's there and how it started. And then on SCT, I'm just going to give you a little progress update. Okay. Before ARM Trusted Firmware, especially in the area of power management, which is, obviously, as I said, one of the areas that I specialized in, we had a bit of a Wild West development model. Essentially, it consisted of 3 steps. A vendor would have some proprietary hardware. They'd add to that some proprietary software. They'd stick it into a blender. And out came some products. Right? And, you know, especially if you're a software guy, then this is probably not the most efficient way of doing things, but we can't knock it. This made a lot of money for a lot of people, and it has been a very successful way of doing things. But particularly as we started to look into enterprise, it was clear that this model is not tenable. It gave us a lot of problems. The first one is varied quality. So some vendors would do a great job of this, and some of them are in this room. I'm always very good to my clients. But some guys actually are pretty good at it. But we also had a lot of vendors that would make a lot of mistakes, and we kept seeing the same mistakes being done over and over. So very varied quality. We also thought this was very expensive because it affected time to market, because everybody was basically solving the same problems over and over again. But the worst problem was fragmentation. And actually, when you looked at power management drivers, for any one kernel, the number of drivers was equal to the number of vendors times the number of SoCs that vendor had. Because often the variation was even SoC to SoC from the same vendor, which is just crazy. So to fix that, we started to create some specs. So the first spec, well, the first 2 specs that really mattered were power state coordination interface and the SMC calling convention. So the power state coordination interface really just defines some common ways of doing power management of CPUs or power domains that have CPUs in them. So a single method for doing secondary call boot, a single method for adding and removing CPUs in hot plug scenarios, a single method for entering idle states. Also, actually, it does some system level operations such as reset and shutdown as well. SMC is the way you do a privilege escalation for ARM architecture. And for things like power state coordination interface to work, we need to use a privilege escalation that's OS agnostic, and SMC gives us that. So we needed to create a specification on how you do SMCs and what the calling convention looks like. But of course, specs mean nothing unless you actually provide some sample code. And actually, that's where ARM Trusted Firmware came to be. So ARM Trusted Firmware was really created around these specs. And I haven't mentioned that there's also a TrustedBoot spec. I'll mention a little bit later as well. But primarily, we actually started doing the PSCI implementation. That was the first motivation and driver for doing ARM Trusted Firmware. And it's an open source project. It used to be BSD and CLA type of model, so BSD and a contribution license agreement. We're actually dropping the CLA, so it's kind of BSD all the way now. And contributions, of course, welcome. And in this open source project, we provide that TrustedBoot early boot phase. You could use it to implement SEC, basically. And we provide the PSCI implementation, all based on the SMC calling convention. And as a result, things have got a lot better. So PSCI is supported by every OS vendor. So Microsoft supports it, Linux supports it, all the distros support it, Zen, KVM, Hyper-V, VMware, everybody supports it. It has become the way of turning CPUs on and doing hot plug and doing idle for ARM v8 cores. And as a result, every silicon vendor that does ARM v8 has pulled it in. And almost everyone has pulled it in from the Trusted Firmware project, rather than rolling their own. A few have rolled their own, but most have taken the Trusted Firmware project. Well, this is a bit of a breakdown of what the ARM architecture looks like. And at the bottom, you've got the most privileged exception level 3. And then on the non-secure side, on exception level 2, we have hypervisors. That's also where UEFI is generally implemented. Exception level 1 is for supervisory kernels, and exception level 0 is for for applications, user mode, basically. And then on the secure side, you have the secure exception level 1, you've got trusted OSs, and you might have some boot firmware, and you can have trusted apps. When we first presented Trusted Firmware, people got very confused because they didn't really know which of all of these levels we were actually providing code in. Trusted Firmware is really just the monitor piece and the sample boot firmware. And so the idea is when hypervisor, say, deems that they want to power up a CPU, they make a call down to the EL3 monitor firmware, which talks to the PSCI library, and the CPU comes up. And for the sample boot firmware, we provide, as I mentioned, for the trusted board boot, some blobs there in Secure EL1 and in EL3. But actually, those are optional, which is a good thing and a bad thing. They're optional because many vendors already had their own custom boot flows, and it's been quite hard work to try and turn them into all using the same one. Bear in mind that in ARM we operate across a really wide space, right, from very embedded right through to enterprise. And in each market segment, people have their own practices, and standardization is about, in some ways, displacing those practices, and that sometimes goes well, so PSCI has gone very, very well. Sometimes it's harder. So how does it relate to UEFI specs? Well, ACPI core power management is intimately tied to PSCI. So in ACPI 6, we introduced LPI power states. And that was a great collaboration effort between ARM, Intel, Microsoft. Qualcomm were hugely involved as well. And actually, the Intel side included Linux guys and Microsoft guys at the same time. And the reason ACPI went from 5.2 to 6 was primarily because of this, because this was a huge change. It's basically the new C states. C states are gone, LPI states are in. And they build entirely on top of PSCI. So, the graphics kind of a bit awry, but idle management piece would talk to LPI states through what's known as functional fixed hardware, and then that calls through into Trusted Firmware. And actually, what's ended up being really nice is that the flow in for an Intel core and the flow for an ARM core actually were very, very similar. It's just stick something into a register and call a sort of escalation privilege instruction. In both cases, it's actually incredibly similar. As I mentioned, we've got a trusted board boot flow, and that provides a reference that you could use to build SEC, and on our reference platforms, that's exactly how it works. And also, for reset, system reset, system shutdown type services, well, it's reset services in UEFI, but functions in PSCI, system reset, system shutdown. We've got a generic library that uses PSCI. There is other work that we're doing in ARM Trusted Firmware. Dong mentioned on his opening talk that PI 1.5 is going to have some ARM support, but given that it's not published, I'm leaving that to the Q&A. So I'm more than happy to take questions on that later. Yeah, so complete vector, SCT update. So we've got a beta version for UEFI 2.5 support. We've done quite a few fixes. Girish sits down here. Was a big participant in that. I think Supreet was the other guy who's already gone. I'm not going to go into detail for any of these fixes. These guys gave me like 20 things to put on the slide, and I said, no, thank you. What I'm going to do is I'm going to point to somebody. And so if you want to know about it, go to talk to him. We've also got an alpha version of for 2.6, so early support for 2.6. GitHubs are both there, so please have a look and play with that. And if you've got any detailed questions, Girish is your man. And also, I think we've talked a lot about SCT in this Plugfest already, about availability and development model. I sent an email actually out with all of the kind of actions end of yesterday, and actually the board's already been talking about some of that. So I'm hoping that this is really going to improve. I think there's a lot of goodwill, and certainly we want to be contributing into that strongly. And yeah, there's also been discussions on the list, and Girish is in that, and Sprit's in that, about proposals to improve with testing partial implementations. This causes a hell of a lot of warnings and messages and problems when sometimes if you're not supporting those things, the test could just be skipped. Is that fair? Yeah. And also, Girish wanted me to point out that we've also run into issues with the robustness of shell, particularly over serial I/O. What is that? Okay, serial I/O protocol. And again, talk to Girish because he's running into problems with that, and I think he'd like to talk to you guys about that.